Hi everyone! Welcome back to Fast Cabling, where we bring you the latest and greatest in technology. Today in this video, we're tackling a challenge that many of you have asked about: expanding Wi-Fi to a remote location using wireless network bridges. Now, whether it is a farm, a research station, or a rural village, reliable internet connectivity is crucial. And if you're struggling with your tech design, you can contact us for a free tech consultation, and we'll work with you to create a custom solution that fits your need. So providing Wi-Fi coverage in remote areas come with its own sets of challenges. These locations often lack the infrastructure that urban areas take for granted, but the benefits of having internet access in these regions are immense. It can improve communication, boost productivity, provide access to online resources, and even enhance safety. So we're going to show you how to overcome these challenges using a combination of wireless network bridges and solar power. So let's start with a quick overview. So our solution involves setting up wireless network bridges to transmit the internet signal over a long distances, and using solar power to keep everything running smoothly, even in the most remote location. Now let's break it down step by step. First, let's talk about the wireless network bridges. Now, what are they and how do they work? A wireless network bridge is a device that connects two or more network segments by using a wireless connection. Think of it as a bridge, but for your internet signal, and it allows you to extend your network over a long distances up to 5 kilometers without the need for physical cables. And there are two main types of wireless network bridges: point-to-point and point-to-multipoint. Now, point-to-point bridges connect two locations directly, like from a main office to a remote building. And point-to-multipoint bridges, on the other hand, connect one central location to multiple remote sites, which is great for covering larger areas. And our wireless bridges here support point-to-multipoint as well. Next, let's talk about the outdoor wireless access points. Now, outdoor wireless access points are rugged, waterproof, weatherproof, and making them perfect for harsh environment. And they work by broadcasting the wireless signal from the network bridge to the nearby devices, and effectively extending your network's coverage area. Now that we know the basics, let's move on to planning your network. The first step is always assessing the area. You will need to determine the coverage areas and identify the line of sight for optimal signal strength, because clear line of sight is crucial for the best performance. So try to avoid any obstacles like trees or buildings. And choosing the right equipment is also essential. For durability and performance, we do recommend our high-quality wireless network bridges and our outdoor wireless access points, because they both equip with gigabit Ethernet port for high-speed transmission and IP65 weatherproof rated casing for harsh environments. And our outdoor WAP support dual bands. So when it comes to frequency band and channels, you might wonder, which one do you use? 2.4 GHz or 5 GHz? Now, 2.4 GHz offer better range but can be crowded, while 5 GHz provide faster speed and less interference, but with a shorter range. So you should choose based on your specific need. Now let's talk about the power solution. There are two main options: traditional power and solar power. Traditional power options include using existing electrical infrastructure. This can be reliable, but it is not always available in remote areas. And PoE, power over Ethernet, is another great option for simplicity and efficiency, allowing you to power devices through one single Ethernet cable. Not to mention, both of our devices support PoE as well. And the other innovative option is using solar power system. You need solar panels, batteries, and charge controllers to create a sustainable power solution. And we do have a new product that integrates all these components into one unit that I'll show you later, and making it easier than ever to set up. And remember, calculating your power requirement is crucial, so you need to consider the power consumption of your equipment and ensure your solar setup can handle it all. So now I'm going to perform a step-by-step guide of the whole installation process. So let's pretend we're at the main building. We have our router here getting the internet access. So I'm going to use Ethernet cable from our router to the PoE injector. This is the LAN port. Plug it in. This is the PoE output port. I'm going to use another short patch cord to connect it to provide both power and data to our wireless bridge here. This is the PoE port. And this is the pairing button. By pressing this button, we can easily pair it with the other bridge. You can also connect to an extra device as well. Now looking at our lights here, you can power it up and make sure they're functioning correctly by checking these indicated lights. So now I'm going to face it in a clear line of sight directly to the other bridge. So we're going to pretend this is the remote location. Now first, you should firmly attach the bridge to the mounting surface. Make sure the bridge is level and facing the direction of the other bridge for the optimal alignment. And our bridge have alignment indicated to help with this process. You can adjust the position until you get the best signal. So for the bridge, we are going to use an Ethernet cable to connect to the PoE port to power it up. And here we go. And next to it, we have our access point. Now this outdoor access point need to strategically place for optimal coverage. You can mount them high in an open area like the pole to minimize obstacles. And make sure the range and the coverage pattern of your wireless access point, alright? And place them too close can cause interference, while place them too far apart can leave dead zone. So you should aim for a balance that provides comprehensive coverage. So now let's open up the cover. We have another Ethernet cable to power it up. So now you may wonder, where are they getting the power from? Those Ethernet cables are connected directly to our outdoor PoE switch to provide the PoE technology. So we have both power and data through a single Ethernet cable. So we have two Ethernet cables connected with the switch. And this switch is powered up by our solar power kit. It is connecting directly here. We have an output voltage of 24 volt, 36 volt, and 48 volt. Now it is set to provide a 48 volt voltage. And we are going to connect the output port. This is the output power cord. And so it can send power to the switch. And here we have the input power cord. This is from directly our solar panel. So let's connect it. So here we go. With this power kit, we have the battery, the solar panel, and the charge controller all in one, so make it very convenient. So now let me turn on our device here. So now we're going to test if we can get the internet access by turning on the Wi-Fi of our mobile device. So this one here is our wireless access point. It is already connected. Now let's go online and see if we can get the internet by pressing the products Here we go. So we can get the internet no problem from the remote location. So lastly, to give you a better idea of how this all comes together, let's look at some real-world examples. So we have case study 1. We can provide the Wi-Fi to a remote farm by setting up a point-to-point bridge from the main building to the barn and using solar power to keep everything running. The farm now has reliable internet access for monitoring crops and livestock. And for case study 2, we can connecting to a remote search station. The scientists at the remote search station can now communicate with their colleague and access online database thanks to the point-to-multipoint network and our integrated solar power solution. And in case study 3, we can expanding the network coverage in a rural village by strategically placing the outdoor wireless access point and using the wireless bridges. We can manage to bring internet access to every corner of the village, improving education and connectivity for everyone. So with the right planning and equipment, extending Wi-Fi to a remote location is not only possible, but also sustainable. Now, thank you very much for joining us at Fast Cabling. If you found this video helpful, please don't forget to give it a thumbs up and also subscribe to our channel for more tech insights and hit the bell icons to stay updated. And I'll see you in the next video.